StreamSets adds great value to the data engineering use case. As part of their analytics initiative, the company is standardizing on Snowflake. A very common pattern here is the need to initially replicate and then synchronize data from on-premise databases with the cloud warehouse. They also need to take data from MongoDB and push that into Snowflake for analytics. Finally, they have typical analytic needs and will want to be able to manage this raw data into proper, slowly changing dimensions. This demonstration will show how StreamSets addresses these critical capabilities. First, we will start with ingesting data from our on-premise database into Snowflake. Because of the schemaless engine, we are able to extract data from one table or all the tables in a single pipeline definition, drastically reducing maintenance and the number of pipelines required to get a job done. Here I've specified to pull data from all the tables in the database. One of the great things about StreamSets is that metadata can be and is carried along with every record. I can see using Preview that the table name that each record came from is available in the record metadata. I can use this metadata or create my own to make decisions like routing, filtering, or modifying data in the pipeline. I can even manipulate that and change it to suit my requirements. For example, changing the employees table to be employees updates before writing to the destination. In the destination, I can use a record expression to drive a configuration parameter, allowing dynamic writing to the appropriate Snowflake table, and in an extra bonus, writing to dynamic folders in a GCS bucket. We can see here that there is no data currently in my GCS folders. Our smart data pipelines give us processing information for each stage, allowing me to quickly see that loading Snowflake is taking the majority of each cycle. Here we can see that a couple of dynamic folders were written in GCS for each incoming table, and each folder contains the table data. On the Snowflake side, with a quick refresh, we can see the tables have been created and loaded. This is typically followed by a change data capture pipeline, where in this case we read the logs from MySQL to propagate changes in near real time to Snowflake. Again, using metadata and dynamic configuration, a single pipeline can propagate changes from many tables. Here we'll change the city of a record in Minnesota, and we will save that in MySQL. And we now see that the pipeline picked that change up and propagated it over to Snowflake. For advanced processing within Snowflake, StreamSets interacts via the new Snowpark API to run pipeline logic fully inside a Snowflake cluster. This allows pipeline processing with normal joins, aggregations, and other common SQL functions, but also advanced processing like slowly changing dimensions, which allow for complete automation of type 1 and 2 dimensions via basic configuration. It also gives you the ability to do things that are difficult in SQL, such as applying a specific function like uppercase to every field in the table as it processes. We can launch this pipeline, and that will translate directly to SnowSQL and execute on the Snowflake cluster. As we start this, the job will run and pick up the change, which we propagated earlier through the CDC pipeline, and apply it to the slowly changing dimension. Moving over to our Snowflake table, the employees table, we can see that employee ID 0 that was there. If we refresh this, we now see a second record with our new city there, an active flag. We've turned off the old one and changed the start and end timestamps on that, affecting the type 2 slowly changing dimension. Through the use of parameters and templates, data engineers can enable others to quickly create pipelines for controlled loading of data with a minimum of effort. So we'll call this one test pipeline, and we can create what are called sample pipelines or templates. We provide a bunch out of the box, but engineers can save their own custom ones as templates for others to use. So when we save and open this into the canvas, we'll see we have a preformed pipeline already leveraging those pre-built fragments for the warehouse, and all I need to do is fill in a couple of parameters and give it a table name. We'll call it self-service, and run the pipeline. So in a matter of a few seconds, an engineer has enabled me to be able to quickly upload data into Snowflake. We can flip over and refresh our Snowflake tables and see that in fact we have the self-service table available to us now. Finally, StreamSets supports pipeline execution on Spark for scalable processing of data. Using the same interface and capabilities, we provide data engineers with the ability to quickly build Spark-based processing, along with the ability to include custom Scala, SQL, and PySpark within the pipeline. In this demo, we have illustrated how StreamSets supports these critical capabilities.